Okay, so you should have sort of settled in nicely now and checked your devices and put them away and turned on the thinking part. You have two handouts. You'll notice that one is white. It looks like this. You can tell because it's white. And you have another one, which is yellow. And of course, yellow means goes in your portfolio. You may realize, looking at this, that there's problems on here. And you may also realize, as you look through it, that there's no link to any answers. Okay? So today what we're going to do is, we're going to complete this one as well. I guess I need to hand these out to do that, right? Okay? So I'll do that in a moment. We're going to look at the last one, which is resistance here. Okay? So you're going to know what resistance is. You're going to understand some causes of resistance. I will ask you on the test, what causes resistance? Fortunately, I will tell you that today, what causes resistance. We're going to solve V equals IR problems. There I gave away the formula. And we're going to know some uses for resistance. And Kaylee needs to sharpen her pencil, so we'll wait for her. I'm going to hand out a sticky. A sticky note. Hopefully there's enough here. Hopefully that'll be close. With your table mate. Or if you don't have one on your own, or I'm sure the two of you guys can get together. I want you to write down, you guys can work as a trio there. Write down what you think resistance is. And you can be wrong about this because it's what you know already. So there's no reason to expect you to know the answer. What do you think resistance means when I talk about electrical resistance? Go, you got like 45 seconds. Go. What do you think resistance means? Here's the guy you can thank for resistance.
All right.
Thank you, George Simon Ohm. In fact, we thanked him so much, what did we do? We named the unit of resistance after him. What do you guys have? You have after this you will. Okay, don't worry about that. George Simon Ohm was a German physicist and mathematician. As a school teacher, yay for teachers, Ohm began his research with the new electrochemical cell invented by the Italian scientist Alessandro Volta. It's fun to say. Alessandro Volta. What do you think we did for him?
Name something after it.
Exactly, the voltage, right? Nicole, the handles are back there already in the grade 9 box at the bottom. So here's what happened. Using equipment of his own creation, Ohm found that there's a direct proportionality between the potential difference, or the voltage, applied across the conductor and the resultant electric current. This relationship is known as Ohm's law because he discovered it. Okay? The greater the voltage, the greater the current. I don't know, what do you guys have to write in there?
Nothing.
Nothing? Well, you got symbol and units, right?
Ohm's law.
Oh yeah, so symbol and units. The symbol for resistance, big surprise, the letter R. Now, here's a little bit of a surprise. Should be the top two there, Nicole. The unit is ohms, and the symbol is omega. The Greek letter O, omega. Okay? You can draw it like that. That's the proper way, but you can just draw it like that. Okay? Yeah, you're going to use that. Like when I ask you to find the resistance, that's you can write ohms or you can put that symbol. Right, Nicole? Yeah, that's fine. Okay, so does this look a little bit like the video that I showed you?
Yeah.
Karen, does this look a little bit like the video that I showed you?
Yeah.
It sure does. As the electrons move through a conductor, they bump into the fixed particles, the atoms in the conductor. So which one are the electrons here? What color?
Gray.
The gray, these guys right here, right? And they're trying to move this way. These are the copper atoms, the sort of the yellow gold ones here. And they're trying to get through them all, bumping into those darn standing around copper atoms. And when they bump into the atoms, the electrons slow down and give up their energy as heat and light. And here's an example of that, or a picture of that, right? When we crank the hand generator, the electrons are bumping into the copper atoms in the filament, giving off heat and light. I'll pause there for a second. Oh. Okay, so I would suggest that. Draw a diagram with your answer. This opposition to the flow of electrons is called resistance. That's the definition for it. It's the opposition to the flow of electrons. Opposition to the flow of electrons. What were the two that I pulled off the wall and said I like these ones?
Not a clue. Was it accurate?
Something that holds back electricity, something that makes electricity move slower. Same idea, right? So, good for those groups that got that ahead of time. I wonder if I'm going to be able to watch this one or if it's going to make me...
Paper trial.
So what do you think Ohm's law is? Okay, so that's Ohm's law. Should we write down the other uses of the formula, the other variations of it? We probably should right here. You did already, Brett? Okay. If you want to include the magic triangle, you would write it like this. It would be V-I-R, like this, right? Which means that if you're solving for I, you cover it up, you got V over R. If you're solving for V, cover it up, so you're going to have I times R. And if you're solving for R, you cover that up, and it's going to be V over I. You're going to need those on your orange sheet, right? That goes in the portfolio. I haven't had them out yet, but I will. I'll give you a chance right away. Now, you might say, Mr. Bennett, I don't care about resistance. I resist learning about it. And I say, shame on you, because resistance has some good uses. Here are some practical examples. Do you like heat in your bedroom? No. You might have baseboard heaters. Do you like grilled cheese?
No. Yeah.
You might have an electric frying pan. Do you like toast?
No.
Do you like electric light bulbs? No. Those are all examples of
my favorite ones
reasons.
Are powered by gerbils.
I would suggest you put a star beside that. Do you know why? Because I have a magic crystal ball that tells me what comes up on the test, Karen.
Show us the crystal ball.
Okay? And that crystal ball tells me that one of the questions is, describe a use of resistance that might be beneficial in your home. You would answer baseboard heaters, electric frying pans, toasters, electric light bulbs, anything else you can think of?
Gerbils.
Gerbils would not get you credit.
Actually, if you put them in a wheel.
Basically anything that creates heat. The computer, I guess, would generate heat. Would that be a useful heat, though? Is that? That's not electrical resistance. Yeah, so I was wrong. Not anything that generates heat, right? The heater consumes power, producing heat for warmth. Frying pan consumes power, producing heat for general cooking. Toaster consumes power, producing heat for cooking toast. And here's the electric light bulb, right there, right? It's very thin, high resistance, gives off heat. Okay, go back. I got two examples for you, and then you're going to do that yellow sheet. A toaster has a resistance of 100 ohms. If the potential difference in an outlet is 120 volts, every outlet in your home is 120 volts. It's standard. Calculate the current. So what are the three letters? Resistance. R equals 100. Potential difference is a fancy way of saying the voltage is 120. You should be writing this down. Calculate the current. What's the letter for current? I. That's what you meant. Go back to the magic triangle. What's the formula for I?
I equals V over R.
I equals V over R. Write the formula. That's the next step. I equals V over R. Noah, are you writing this down? This example? Good. So the current, right underneath it, line up your equal signs. Voltage is 120. R is 100. Maybe you can do that in your head. 1.2 what? Amps. 1.2 amps. How come some devices have these kind of gizmos?
A transformer.
Yeah. What does that do?
It converts it to a lower or higher.
To a lower voltage. This one here, your computer. You'll notice on here it'll likely say in really fine print, and I'm going to have to look really hard here to see. It'll say input 120 volts, output 19.5 volts. How come?
Because it's too much for a laptop.
Yeah, laptop doesn't need that much.
So it's that.
Yeah, too much. Where else do you see those? What other kind of devices? What about, got one of these at home? Or with you? Probably, if you didn't have, this is a transformer as well. It like it says on here. Can you read that? Because that's way too small.
1.5 volts.
1.5 volts? So it takes 120 volts, knocks it down to 1.5? Carry.
Yeah.
That's it. Yeah. 180, 1 amp. Might say on yours, Kenny, does it? Stop. No, stop. Okay. Here's the last example. This is the hardest one you're going to see. 5 volts? Okay. Let's try this one. Last one, and then I'm going to give you some time to work. No one, you need to watch carefully and think. Here we go. 15 coulombs of charge are moving through a wire in a minute. If a 100 ohm resistor is added to the circuit, what would be the potential difference? And the hint is you're going to need two different formulas. Let's find out what we know. Is there any other numbers given in the question? 1 minute, exactly. But it's written in words. Okay, so 15 coulombs of charge. Karen, what's the letter for charge? Q. So Q is equal to how much? 15. Are moving through a wire in a minute. Savannah, what do I write? 60 seconds. You probably don't need to write 1 times 60. Oh, did I do that?
No,
That's
it
not
just
good.
it
Thank you.
grew up.
No, it was me. It was me. T is equal to 60. If a 100 ohm resistor, Nolan, what do I write? 100 ohm resistor. R equals 100 is added to the circuit. What would be the potential difference? So we're solving for V. How come I got 4 letters? When you got more than 3 letters, it's going to be a 2-step problem. It's like the country version. 2-step? Thank you. Thank you very much. Like, buy my book with all my latest jokes. Okay, no, I should write one with all my greatest jokes. It would be a real seller. You'd be in the basement. That's how much of a seller it would be. Yeah, that's another one, yeah. I'm giving it away for free. Okay, what formula has V in it? V equals I times R? I think it is. You're right. V equals I times R. Do I have I? Oh, sadness. Do I have R?
Yeah.
I have R. So if I could find I could use this. So I'm going to put this over here.
Wait, what?
Oh, you can do that.
Yeah.
What's crap?
Oh, you guys can't do that?
No.
Could I find I? Do I have a formula for I? I do. I is equal to Q over T. So I'm going to solve I is equal to Q over T. Does this I equal that I?
Yeah.
I, Captain. And so I'm going to solve for I, and I'm going to plug it in there. I equals, what's my value for Q? 15. My value for T is 60.
0.25.
0.25 what? Amps. Bailey, are you watching? 0.25 amps, and what do I do with my 0.25 amps? I put it up in there for that I, because the I is the same. It's a two-step problem. So I 0.25 times my resistance of 100.
25 volts.
1.25 times 100. Teague is right, 25 volts. Look at that. Junior electrician in the making. 52 volts? Okay. I'm going to be quiet for the rest of the period. This goes in your portfolio. This is the hand-in assignment. You must complete it. Okay? There are lots of questions here. There are no answers. How come? And it's a little quiz. It's an assignment. You have to hand it. It doesn't have to be handed in today, but it must be handed in. You do not write the test until I know you can do this. Yeah, I'm going to handle it. It's all three problems. All three formulas.